Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's session we are going to discuss a numerical example on the topic center of gravity of symmetrical sections. Let's go to the numerical. Find the center of gravity of a 100 mm multiplied with 150 mm multiplied with 30 mm T section. This only that question. The diagram is not a given one. So based upon that, we have to draw the diagram. So I have drawn the diagram based upon that question. Okay. That is this upper flange width, that is 100 mm, that overall height, that is 150 mm, and then the thickness of the two rectangles. This will be 30 and this also 30 mm. Actually, it is a T section and it is symmetry about the vertical axis. Okay. And here you can see the center of gravity means it's a point. But actually here we are going to calculate the distance of center of gravity from the reference axis. Okay. Here the x bar and y bar, the two distances we will calculate. Here for the y bar, we will take the bottommost line as the reference. Okay, for an example, in case the center of gravity is here, what will be the distance of that center of gravity from the bottommost reference line? That is here we are going to mention as y bar. Same way, for the x bar, we are going to take the leftmost line. Here you can see this is the leftmost line in this diagram. Same, this one is the bottommost line in this diagram. Here, this is symmetry about the vertical axis. Okay. It means that you can consider the center of gravity of the section, this considered T section, that may be here, whatever. But that should be lies on this vertical axis, since this symmetry, that means this T section is symmetry about the vertical axis. So wherever the center of gravity lies on the vertical axis, the distance from the reference axis, okay, for x bar, that will be same wherever it may be. That means if the center of gravity is here, from here also the same distance. So the x bar, since it is symmetry about the vertical axis, here we are not going to calculate the x bar. Do you understand? Because the x bar will be the total distance, 100 mm divided by 2, that will be 50 mm. So only here we are going to calculate the y bar value. Okay. And then here, this will be the reference axis for y bar. And this given diagram, we are going to separate into small areas for our convenience. Here, this T section can be considered as two rectangles, like this one. Okay, that is rectangle 1, and this one, that will be the rectangle 2. Actually, guys, the whole center of gravity formulas, that and all, discussed in a separate video, and that video link is attached in the description box of this video. Okay, to watch the reference videos, just to go to the description box of this video and click the video link and just to see the reference video. That will be better to understand this concept. Same way that another one video, one is the overview of center of gravity. In that, I explained the formulas of the different areas and volumes. Okay, that things and all we discussed. Then another one video, that is center of gravity by moment method. In that, how can you get the formulas for x bar, y bar, even z bar also? When you consider the masses, when you consider the volumes, when you consider the areas. Okay. So that and all discussed in very clearly it is discussed. That video link also given here. Okay. So go to the description box, the two videos, an overview of center of gravity, then center of gravity by moment method. Okay. So watch the two videos that will be convenient to understand this numerical. Okay. So now we will go to the numerical. So here, first thing, we are going to analyze the data for the rectangle 1. Okay. So first, the rectangle 1. Here, I just write the formula of y bar, what here we are going to calculate. Actually, here you can see these two rectangles are given as area. So area only we are going to consider here. That means we can consider a mass, volume or area with respect to the given condition. Here it is the plane figure. That means like a rectangle. So we are going to consider only the areas. Okay, center of gravity of the area. That formula will be here y bar we are going to calculate and two areas we have. So y bar equal a1 y1 plus a2 y2 divided by a1 plus a2. If this is the plane figures, then here area will be there. If it is the volume 3D objects, then v1 v2 divided by v1 v2, like that it will be there. If you consider the entire object as a mass, then instead of area here m1 m2 that will be there. That things I explained clearly in the center of gravity by moment method. Okay, so first I start with the rectangle 1. Here you can see we need the values a1 and y1 to calculate the y bar. So for the first rectangle, you know the area, that means area of the rectangle, that is length into breadth. Okay, area of the rectangle, the general formula is length multiplied with the breadth. So here for the first rectangle, the length is 100 and the breadth is 30. So you can substitute 100 multiplied with 30. So you will get 3000 mm square. Okay, we will get 3000 mm square. Okay. Then y1. Actually, for the rectangle, the center of gravity, that will be L by 2 the distance, B by 2 the distance. Okay. So for y bar, it will be B by 2. That means from this point we can take. Okay. If it is 30 mm, that will be 30 by 2. That means actually the CG will be here. So this will be 30 by 2, that is 15. But here we have to calculate this y1, that is distance of the center of gravity of the rectangle 1 from the reference. Okay, this is actually the reference axis for y bar. Okay, so here you can see from this the distance is 30 mm. Okay, but we need the distance from the reference. So you know from here to here, if it is 150 mm and this dimension is 30 mm, this one, okay, that actually we know that is 120 mm. Okay, so from the reference axis to this point, that is 120, and from here to here, that means here the center of gravity of the first rectangle will be here. Okay, L by 2 and B by 2. So up to this 120 plus 30 by 2. So we can write 120 plus 30 divided by 2. It will be 15. So we will get 135 mm. Same we have to analyze for the rectangle 2. Okay. For the rectangle 2, same, we have to calculate the area. Here, this height 120 mm, The breadth is 30 mm. So the A2, that will be 120 multiplied with 30. So you will get 3600 mm square. And then Y2. Here you can see the second rectangle just lies on the reference axis. So from here, actually the center of gravity will be, if it is 120, then that will be the center of gravity possibly here. That means 120 by 2. Okay, this is CG of 2. Okay, center of gravity will be probably here. So from here, if you had taken 120 by 2, from the reference axis, that will be 60 mm. Okay, so now finally we are going to calculate the center of gravity, that by using the formula y bar equal a1 y1 plus a2 y2 divided by a1 plus a2. Substitute all the values whatever we had found here. Y bar equal a1 3000 multiplied with y1, that is 135, plus a2, that is 3600 multiplied with y2 value, that is 60, divided by a1 3000 plus a2, that is 3600. If you simplify, we will get the value of y bar, that is 94.1 mm. Actually, this is the distance of center of gravity of the area, whatever given. That means the T section from the reference axis. For y bar, the reference axis will be the bottommost line. Okay. Actually, I think up to this, it will be 60 mm. So probably it will be here. So the center of gravity of the whole section, that will be from the reference at a distance 94.1 mm. And here x bar is not needed, but if you need the x bar equal to 50 mm, because the center of gravity of the T section from the reference axis, if this is the reference, from here, this distance, horizontal distance will be 100 by 2, that is 50 mm. Okay. So I hope you all understand. Again, I'm telling, for the reference video, an overview of center of gravity and center of gravity by moment method. Okay. So for both videos, just to go to the description box, then click the necessary link. You can see the reference videos. Okay. I hope you all understand this video. For more center of gravity related videos, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Okay. Thank you guys. Thanks for watching.